Hi, welcome back. In today's video, we're going to talk about how we can use name tuples to store employees' data in an organization or in a company. So I'm having my named tuple here, and I use the employee name, and there are four elements here, as you see. The first one is ID, the second one is name, the third one is department, and the fourth one is salary. Then we are creating two instances, E1 and E2. In E1, we are storing information of John Doe, whose ID is 101, and he's from the engineering department, and his salary is 80,000. Then we are having the instance 2 being created here, and his ID is 102, and we're talking about Jane Smith, and this person is from the HR department, and the salary is 60,000. Now that we stored the data in our named tuple using our instance, we would like to access it. In order to access it, it's very easy. We write down the name of the instance that we created, then we put a dot, and then we write down the element name. For example, here is the name, then the department. So now it's going to print us the name of the first person and the department of the first person. And this line helps us to have the salary of the second person because we are using E2. So when I run this code, we see John Doe Engineering, and 60,000 is the salary that is printed for the salary of the second person. So we could say here the salary of the second employee is, so this message could help us to have a nicer output. For example, here the salary of the second employee is, sorry, there should be a space there, employee is 60,000. And here we could say, for example, the name of the first employee is, and here we could say, for example, the department of the first employee is. So when I run this code, we see these messages helping us to understand the output better. So the name of the first employee is John Doe, the department of the first employee is engineering, and the salary of the second employee is 60,000. This is how we can use named tuple to store, for example, information regarding our employee in a company. And this was a good example to have, for example, 4 elements in our named tuple. Thank you for watching. Hi, welcome back. In today's video, we would like to use named tuple to represent colors. We would like to store color values in red, green, and blue format. Here is my named tuple called color, and it has 3 elements, red, green, and blue. Then we would like to define some colors using instances. So the first instance called white, the second instance called black, and the third instance called red. For example, for the color white, we have the values in red, green, and blue format. And the value for this instance is, for red is 255, 255 for the green, and 255 for the blue. Okay, so the elements in the white that gets different values are 255 for red, green, and blue, all of them. Then the second instance is created. Let me write it down. Maybe it's second instance, first instance, third instance. Okay, so the second instance is created from the color named tuple, and it has values equal to 0 for red, green, and blue. Then the third and last instance is created here, and for the name tuple color, it has only value for the red, and for the green and blue has 0 values. Okay, so this is just an assumption, just an example. We are just creating, don't be confused with the numbers here that we are creating. We're just making an assumption here to create an instance. The important thing is that this is the instance. We can say inst1, inst2, inst3 instead of having white, black, and red. Okay. Then in order to access the elements that are stored in instance 1, we write down white.red, because this is this red that we are talking about and not this red. Okay. Then we are having white.green and white.blue, because we learned that we write down the name of the instance dot the name of the element, which are red, green, and blue in these cases. Okay. So when I run this code, we see the output is exactly like this one. So if I copy this and paste it here, okay, and instead of white, I write down, for example, black. Now we are going to see the output for instance named black for different elements red, green, and blue for our named tuple. And we expect to see 3 zeros in the output. Exactly, we see it. Then if we have it now for the red, and the red. So when I run this code, we expect to see first red to be 255, because we created the instance with these numbers, and then 2 zeros. So when I run this code, we see 255. So this first red is our object here, our instance here that we created. The second red is the element inside our named tuple. This is the most important part about this example, this coding exercise. Then we have the red again, dot green. This is the green. And then we are having the red again and dot blue, which is here. Thank you for watching. Hi, welcome back. In today's video, we would like to integrate the concept of named tuple with functions. Here, we are having our named tuple called a rectangle. It has 3 elements: width, height, and area. Okay. Then we are having a function called getRectangle. And whenever we call this function, we need to have 2 arguments. Then this function is going to calculate the area of the rectangle based on the passed arguments that are width and height respectively. So area equals width multiplied by height, and basically this function is going to return a rectangle named tuple with width, height, and area. So the output of this function is in the format of our named tuple. So this is how a function actually trying to return multiple values in a structured way. But how are we going to use that? Here, before we learned that if we want to have, for example, if we want to create an instance, we name the instance, for example, instance1 equal to rectangle, the name of our named tuple, and in parentheses, we were having, for example, number 5, 10, and the area. If we wanted to calculate it ourselves, we would have written, for example, 50. Okay. But instead of creating an instance like this, being equal to the name of our name tuple, and then in parentheses having these 3 elements, okay, instead of doing that, my instance now equals to a call of function, and we are calling this getRectangle function with 2 values, width and height, and this function is going to return what we were supposed to have. Okay, rectangle 5, 10, 50. It is going to return rectangle, the name tuple, width, height, and area all of them, the function has access to it, because the width and height, we call the function with those numbers, so 5 and 10, it already has. And for the area, it just calculated the area here, okay? Width multiplied by height. So instead of writing the instance like this, we write down the instance, it is equal to a callout function, and that function is going to return what we need here, okay? Then after creating our instance, we are going to print in the output saying that, okay, the width is the name of the instance dot the name of the element, like always, the height, the name of the instance, like the name of the element, and the name of the instance, and then the name of the element. So when I run this code, we see it says width 5, height 10, and area 50. It's a very good example to see how we can integrate named tuple with a function. For example, here let me create another instance. So instance 2 get rectangle, and with these values, for example 10 and for example 15. So when I have this one, whenever we are creating the instance, right away we are calling the function. So compiler starts executing this part, calculating the area, and returning the name tuple that needs to be equal to my instance. Then I use the same line here, but instead of the rect, which is the first instance, I write down the name of my second instance, which is instance 2. So when I run the code, this time it says width 10, height 15, and then area 150 based on the calculation that the function did for us. Thank you for watching. Hi, welcome back. In today's video, we are going to talk about how to convert a name tuple to a dictionary. Here is the name tuple called person. Then we are having the fields, or let's say the elements. The fields are name, age, and city. After that, we are creating an instance of the person named tuple, and the instance has this information: Alice, which is the name, 30, which is the age, and then the New York, which is the city. Okay. Now we created our instance, and now we would like to convert this to a dictionary. In order to do that, we simply write down the instance name dot underscore ASDICT, this code, underscore ASDIC, with empty parentheses, and assign it to a new variable name, for example, person dictionary. Okay. Basically, this function that we're talking about here, returns an ordered dictionary where field names that are name, age, and city are keys, and values that we're having here are from the named tuple. Okay, so basically what it is going to do is the following. It is going to have, for example, name. It is going to have name Alice. Okay, then we are going to have age 30, then we are going to have city, and then New York. Okay, so we see that as we defined here, the fields in our name tuple that are name, age, and city are keys in our dictionary name, age, and city, and these name tuple information are our values here. You see, Alice is the value for the name key, 30 is the value for the age key, and also New York is the value for the city key. So this function is going to do this for us. Convert the name tuple instance to a dictionary using this function. And simply we are going to print person dictionary, and when I run this code, we exactly see what we expected here. We see that name, age, and city, the fields of our name tuple, are the keys in this dictionary. And then the values are Alice, 30, and New York. Actually, this function is a built-in function in Python for named tuple instances. And basically, this method is useful when we need a dictionary-based data access. In order to have a dictionary-based data access, we are going to convert the named tuple instance to a dictionary simply using this function. Thank you for watching. Hi, welcome back. In today's video, we are going to create a named tuple called car, and it has three fields: brand, model, and year. We learned that named tuple are immutable, so we cannot modify them, but we can use the underscore replace function to create a modified copy of the instance for the name tuple. So here is my name tuple called car, three fields. Then we are creating an instance of the car name tuple, which is Toyota, Corolla, and the year is 2020. And we know that we cannot modify that, but we can create a modified copy. In order to create a modified copy, I write down the name of the instance, dot, then underscore replace. In parentheses, we are having the year equal 2023. So instead of 2020, I would like it to be 2023. And all these modified copy is assigned to new car. So now I print my car and new car. So when I run the code, we see that the original instance, which is my car, has the Toyota Corolla year 2020, but the modified one is the Toyota Corolla year 2023. So this is how we can use the underscore replace function to have a modified copy of the original instance. For example, I would like to modify the brand, for example. I write down new car 2, it's the name of my instance and it is assigned to be equal to my car dot replace. So we are going to assign the brand BMW to this instance instead of Toyota. Okay, so we are creating a new instance. We are replacing the new brand. So Toyota is not assigned to the new instance. BMW, however, is assigned, but for example, the model is Corolla still, and the year is 2020. Okay, so when I run the code, it makes no sense to have a brand and with the model Corolla, so we can have also this modification as well. So new car, here we could have, for example, model equal X5, for example. Okay, so when I run this code, we need to print the instance as well to see it in the output. Okay, now we are having the original instance that we created here, Toyota Corolla 2020, we see it. Then we created a modified copy of the first instance, and instead of the year 2020, we assigned year 2023 and assigned it to new car instance. So we print new car, we see it here, Toyota Corolla and 2023. And finally, we created another new instance called new car 2, and we replaced the brand and the model, and the year is still the same, so it's 2020, but the brand is now BMW, and then the model is X5. So we see when we print this object, in this instance, we see that brand is BMW, the model is X5, and the year is 2020. So this is how basically we can create a modified copy of our name tuple in Python. Thank you for watching. Hi, welcome back. In today's video, we are going to talk about deck. They are double-ended code. And in Python, a deck is a list-like container that allows fast appends and pops from both ends, from the beginning and from the end of the deck, okay? And there are a few examples why we need to use deck in our codes. So there are faster performance for insertion and deletion as compared to lists in Python. They are efficient for first in, first out queues and also useful for last in, first out system. And they have a fixed length queues for recent data and they support fast rotations. But what these things mean, we're going to dive now into the code to see what are these things that we are talking about. In order to use deck, we are going to have the deck being imported from the collection module. Then we are creating one. Here is the name of my deck, which is DQ. And these are the elements 1, 2, 3, 4, and 5. And this deck is created and assigned to DQ. Basically, I am printing out the initial deck in the output. As you see, the initial deck, we see 1, 2, 3, 4, and 5. But how can we append some elements into our deck? In order to append from right, we can simply write down DQ append. And for example, now I would like to append number 6. And using this code, I can append number 6. So when I run this code, we see after appending 6, deck looks like something like this. So 1, 2, 3, 4, 5, 6. 6 is added on the right side of my initial deck. So here is the code. DQ, the name of my deck, and dot append. In parentheses, we write down the value that we want to be added to our deck, and simply I'm printing it here. But what if we want to append one element from left? In order to append from left, we write down the name of the deck dot append left. In parentheses, we write down the value. Now I am appending one value from the left to my deck, which is 0. The value is 0. When I run this code, you see that after appending 0, this was my previous deck. Now you see 0 has been added from the left-hand side. So previously we learned how to add 6 from the right side. Now we are adding 0 from the left side. So this is how we can append either from right or from left. It's very easy and it's very fast. And in order to pop from right, we simply write down DQ, the name of the deck, dot pop, and empty parentheses. So when I run, you see that we are popping from the right. So the 6 is being removed as the last element of my deck. So 0 to 5 is being created there. So 6 has been removed, or let's say we are popping from right simply by using the pop function. And in order to have pop from the left hand side, it's possible to simply write pop left. Okay, so when I run this code, now this is the last version of that we had. After that, we did the popping from left. So 0 has been removed as well. So 0, we don't have it. 6, we don't have it anymore. Now we are having a deck like this. 1, 2, 3, 4, and 5. Then in order to extend our deck, we can have the extend keyword and then the numbers that we want to be added at the right of our deck. So 7, 8, and 9. So when I run this code, on the right side of our deck, we'll see 7, 8, and 9. So here, after extending at right, we are having 1, 2, 3, 4, 5. So far, it was the previous version. And then 7, 8, 9 are added to our deck here, okay? Then in order to extend from left, we can again have the keyword extend, but from left, so extend left. Then we write down the numbers, -1, -2, and -3. So when I run this code, we expect to see from the left to be extended. So we are seeing -3, -2, -1, then 1, 2, 3, 4, 5, 6. 6 we don't have, 1 to 5, and then 7, 8, 9. So here is extending from left hand side. We are having -3, -2, -1, and then 1, 2, 3, 4, 5, and then 7, 8, and 9. So when we are extending from left, we are having the lower number being shown on the left part, which is -3 in our case here, okay? And then we are having the rotation on the right hand side. So if we want to rotate from the right, we simply write rotate, and we mention by 2. So by 2 values and elements, we would like to rotate them. So 2 values or 2 elements, we want to rotate them. Here you see, this was my previous version. When we rotate from right 2 elements, these 8 and 9 are not here on the right side, but they are on the left side. So when rotating from the right side, these two numbers we mentioned because we want to rotate 2 elements. In parentheses, we put the number 2. So we see that these 2 last numbers are assigned to the left side of our deck here. You see 8 and 9 are there. So if we want to rotate from the left side, we can have rotate -2. Now I want to have 2 elements from the left side. So I write down 2 because I want to rotate 2 elements. And I write -2 because I want it to be done from the left side. So when I run this code, these 2, 8, and 9 are back in the last version to where they were. So we are rotating from left and putting them on the right side of our deck here. Then we can create a new deck with a maximum length. For example, here we are having a deck that has 3 elements, and we mentioned that the maximum length of this deck is 5. So now it has 3 elements only, and we print this deck underscore max. So we see that, okay, it has 3 elements, and the maximum size of this deck is 5. Therefore, it has 2 remaining elements to be added. Okay, in order to add new elements, we are adding 40. Let me uncomment them one by one. So now I try to append 40 on the right side of deck max. When I run the code, you see 40 is added there. Okay, now if I uncomment this, we will see 40 and 50 is added. So 10, 20, 30, 40, and 50. And maximum length is 5. So we are having 5 elements. But if I want to append another number, what would happen? So if I add another number, when we are having the maximum number in this deck, because the maximum length is 5 and we are already having 5 elements there. So if I add a new number, it is going to remove this 10 number. This number 10 is going to be removed. So when I run the code, you see now 10 has been removed and 60 has been inserted. If I add another number, 20 will be removed and another number will be inserted here. So in this video, we saw what the deck is and how we can append and pop elements from the right side or from the left side. And also we learned that they are faster, they're having faster performance for insertion and deletion as compared to lists. And we saw that we can have a fixed length size for our data. In this example, we were dealing with a fixed size, and we saw how we can simply have the rotation of our elements. We rotate 2 elements from right, so it means that we took the last 2 elements, insert them in the beginning, and then we can take the first 2 elements and put them on the end of our deck. So it's very easy. And we are going to have some coding exercises to see how the first in, first out would work and how last in, first out would work. So let me review the code. Here is how we created and initialized our deck. Here is how we appended an element from the right side, how we appended from the left side, how we popped from the right side, let's say to delete an element from right side, and how to do that on the left side, how to extend it. We extended and we added these three numbers, how to extend from left, how to extend from right, how to rotate from right by how many elements. So here 2, you can say 5, 3, whatever. How to rotate from left, we must use the minus and then the number of elements like 2, 3, 4, 5. How to declare and create a deck with maximum length and how to print that, and the policy regarding appending new elements to one deck that has a maximum size that we learned about in this video. Thank you for watching. In the following videos, we're going to have some coding exercises with respect to this topic. Hi, welcome back. Here we're going to discuss first in, first out concept for deck. Here we are initializing a deck called Q. Then we are appending three elements to the Q, so A, B, and C. So this is the first part, the creation part, okay? This part is the appending part, so we are appending three elements to our Q, and then printing part, okay? Printing. Now we would like to remove one element from left, and then we want to print the output. So because we are following the first in, first out concept, whatever that comes in first, it is going to be removed first. Therefore, we can use the pop left function to remove the first entered element in this queue. Let me print this once here. So when I print our queue here, let me comment these two lines. So when I run the code, we see that here we created the deck, we appended three elements, and we printed it. So A, B, and C. So first of all, we added A, then we added B, and then we added C. Now the first in was A. So if we want to have first in, first out policy, A should be removed. In order to remove A, because it's the first element from left, we simply use the pop left function in order to remove that. And as you see here, we are removing the element A, and if I print the whole deck, you will see that it will have now elements B and C. So this is how actually we can have first in, first out policy in deck. Thank you. Hi, welcome back. In today's video, we are going to talk about last in, first out policy in deck. So here is my deck. We are creating it. It is called stack, and we are appending three elements to it. So X, Y, and Z are appended to the stack. Then we are printing the stack. So when I run the code, we see the original stack. X, Y, and Z are three of them. All of them are added. So now the last in element was this Z, and we want to have the last in, first out. So the last element that entered, we want to take it first. Okay, so Z we inserted at last, and we want to start removing from Z. Okay, in order to start removing from Z, we simply use the pop function that is going to remove from the right hand side where the last inserted element is stored. So we use the stack.pop with empty parentheses, and then I print the last element that is being removed, which is Z here, and finally I print the full deck in the output, and we see now we are having X and Y and Z indeed has been removed. So here in this example, we learned that we can do the last in, first out using deck. Thank you for watching. Hi, welcome to this video. In today's video, we're going to talk about ordered dictionaries. So an ordered dictionary works like a regular dictionary, but the important thing about the ordered dictionary is that they remember the insertion order of keys. So an ordered dictionary is a dictionary that remembers the order in which keys were inserted into this dictionary, and they are very useful. For example, they can maintain the order. Unlike the older version of Python dictionaries, ordered dictionary keeps a key insertion order. It's very important, particularly if we are talking about if you're working with JSON processing or, for example, configuration files, and these are the situations in which the order is very important. So when the order is very important for us, it's better to use the ordered dictionary. They are ideal for this situation, and they support move to end function, which helps us to reorder the elements. So in the following videos, we are going to do some coding exercises with respect to different aspects of ordered dictionary, so you see that how we can use them, implement them, and how useful they are. Thank you for watching. Hi, welcome back. In today's video, we are going to dive deeper into the concept of ordered dictionary, and we are going to learn how to declare them and how to work with them in a few coding exercises. First of all, in order to work with them, we need to import ordered dictionary from the collection module in Python. Then, in order to create an ordered dictionary, we need to write down the name that we want to have for our ordered dictionary. Then we are assigning it to order dict in empty parentheses. So the name of the order dictionary equals then the keyword of order dictionary and with empty parentheses. Now we created our order dictionary, with the name OD. Okay, and now we would like to have its element. For example, we can have for the element with the key A the value of 1. As we remember, we mentioned that it's like a normal dictionary with different features. Because it's like a normal dictionary, it has keys and values. So for example, it has the key 1, value 1, okay? So for example, if we are having it in parentheses, then we are having key 2, value 2, for example, etc. until the end. So different keys, different associated values. Here is our first key, which is A, and its value is 1. Then we are having another key, which is B, and its associated value is 2. And we are having a key that is C equals to an associated value equals to 3. And then we are going to print our order dictionary, which is called OD. So when I run this code and we come here, we see the output here. We see that we are having the order dictionary being printed. So it says A1, so the second key, the second associated value, B and 2 and C and 3. So this is how actually we can have our order dictionary being created and declared. Now let us do some more coding exercise with respect to order dictionary. So in order to access one particular element, how do we do that? For example, if we want to print only the second element of our order dictionary, how do we do that? In order to do that, in order to access a specific element in an order dictionary, we simply write a message, for example, the value for the key B, so it's clear in the output. We can trace it easily. Then we are having the name of our order dictionary. Then we simply write down the key in quotes. So it is going to get the key, that specific key, and then from the OD order dictionary. So when I run this code, we see that it says value for key B is 2. And this part is our message. You see, value for key B is 2. This is the message that we wrote to be printed. And this is the part we can access the value of the key B from the OD order dictionary. Okay, so this is why 2 is being printed, because we assign number 2 to it. But if I, for example, want to have another value for another key, we can simply write down, for example, value for key C colon order dictionary, then C. Okay, so this is how we can have our order dictionary here. Let me comment this part for the moment. Okay, now I'm trying to show the value associated to key with key C here. And in order to access that, simply we write the key name in the code here from the order dictionary called OD. And we expect that in the output we see number 3 as well. So when I run this code, in the output again we see value for key C equals 3. So this is how actually we can access different elements of an order dictionary. Now let us do another example. What if we want to update the values? So here for the key A, we are having its associated value equal to 1. However, what if we want that 1 to be updated and be equal to 10, for example? Simply, in order to do that, on the left-hand side, we write down the name of our order dictionary. In our case, it is OD. Then we are having the key name that we want to work with in the code. So A is there, and it equals number 10. Now, this way, we are trying to update the value associated with the key A from the ordered dictionary. When I run this code in this part, we are printing again the full order dictionary to see what happens after updating A here. So I go down, we see that after updating A, this message is shown. Then it says A is 10, B is 2, and C is 3. So you see here A equals 10, while A was equal to number 1 previously. So this is how we can update the value of A. Here also we can, for example, update another value. For example, here I would like to update the value associated with the key B. For example, I write down again the name of my order dictionary and the key, which is B here, equals 20. So now I am assigning number 20 to the associated value with the key B from the order dictionary called OD. Okay. Then we print it after updating B, and we are going to print the full order dictionary. When I run the code here in the output, we see that, okay, after updating B, A is 10, B is 20, and C is 3, and you see B is 20 and B was equal to 2 previously. So this is also how we can update the order dictionary. Now, what if we want to move one element to the end? In order to do that, for example, we would like to move the key B from the order dictionary OD, and for doing that, we need to use move to end function, move underscore to underscore end. So using this function, we can assign the key B to the end of the order dictionary OD. After doing that, we simply print after moving B to end, we see that here we are having the print of the OD. So when I run the code, we expect that now the key B should not be the second key, but the last key. Okay, so we come here, we see that after moving B to end, we see that A equals 10, C equals 3, and then B equals 20. Previously, we were having A, B, and C, but now we are having A, C, and B. So this is how actually we can move one key to the end. And okay, now what if we want to move, for example, now A to the end? So if I want to move A to the end, again, I write down the name of my order dictionary, then I use the function move to end, and then here I write down, for example, A. This is how I can move A to the end, and then I simply print the order dictionary and the message saying that after moving A to end. So after moving A to end, we are printing the full order dictionary, and this was the way to send A to the end. For example, in order to send the key A with its associated value to the end, we write down the key A, then we write down move to end, and we use the move to end function to do that. In parentheses, we write down the name of the key, and in the beginning, we should start with the name of our order dictionary, which is OD. Then I print the full order dictionary. So when I run this code, we see that it says after moving A to the end, we see previously it was like this. So A, C, and B. Now we sent A to the end. So A is there and in the end. Then B is in the middle, and we start with C here. Okay? Because A was the beginning and C was the second one. Now A is sent to the last one, and that C, which was the middle one, is now the starting point of our order dictionary. Then, for example, what if we want to send one key to the beginning? So let me now send A to the beginning again. Here, I'm updating this. For example, here, I want to send one key of our order dictionary to be the first key. Here, you see that C is the first key. Now I want to have A as the first key again. How to send it to the beginning of our order dictionary? In order to do that, we simply write down the name of our order dictionary, then the function name move to end. But this time in parentheses, we need to have two arguments. The first argument is the key that we want to send to the beginning of our order dictionary, and it is separated by a comma from the second argument, and the second argument simply says last equals false. This last equals false will help us to send the key A to the beginning of the order dictionary OD. And here I'm printing out after moving A to the beginning, then we are having the OD. So when I run this code, we see the output after moving A to the beginning, we are having the order dictionary A again is the first key, then C, and then B. While in the last version, in the previous version, we were having A as the last key. Now, thanks to the move to end with the last equals false argument, we are having A key being the first key in our ordered dictionary. What if now we want to send B, for example, to be the first ordered dictionary key. In order to do that, for example, I can again write down the name of my ordered dictionary, then move to end, and then we are having, for example, B here, last equals false, and then we are going to print it. So now I want the key B to be the first key using this keyword of the order dictionary OD, and we are using the move to end function. So now B will be the first key of the order dictionary OD using the move to end function and the last equals false argument. After that, we are saying after moving B to beginning, we are printing the order dictionary, and you see in the previous version, B was the last key. Now, thanks to the move to end function with the last equals false argument, we are having B as the first key. So B 20, A 10, and C 3. So this is how actually we can move one key to the end or the beginning. So how about removing or deleting an element? In order to delete an element, we write down the del keyword, the name of our order dictionary, which is OD, and then the key that we want to be removed. Now I'm removing the key A from the order dictionary OD, and then we are printing the order dictionary one more time. So when I run this code, we see that after deleting A, order dictionary looks like this. We are having B equals to 20, and the key C has its associated value 3, and A, which was 10, is now not included in our order dictionary because we just removed it. Then we would like to compare a normal dictionary with an order dictionary. Here we are asking the compiler, we are having two uh, normal dictionaries and we're comparing them. So it has three, each of them is having three keys and their associated value. For example, X, Y, and Z. X is 100, Y is 200, and Z is 300. And we see that Z is 300, X is 100, and Y is 200. But in the second normal dictionary, we are changing the place of the dictionary. For example, Y was the second key, now it's the first key. X was the first key in the first dictionary, and it is now the second key in the second dictionary. And we are asking the compiler to see our normal dictionaries equal, and we are assigning dictionary 1 to be equal to dictionary 2, and we want to see if the result of this is true or false. So when I run this code, it says, are normal dictionary equal? The answer is true. So the compiler sees these two normal dictionary to be equal. However, when working with order dictionary, we are having two orders dictionaries here. So the order dictionary 1 and the order dictionary 2. So X, Y, and Z, 100, 200, and 300. Then Y is 200, X is 100, and Z is 300 in the second order dictionary. And we see that the keys are the same, the values are the same. However, the place where we are having Y in the first one and the second one is different, and also the same logic happens with the X here, okay? And we are asking the compiler to see are ordered dictionaries equal, and we are asking the compiler this using the order dictionary 1 equals order dictionary 2. So when I run this code, the answer is false. So these two order dictionary are not identical because the order in which the keys are inserted is very important in the order dictionary. This is why the compiler does not see them to be equal to each other, So in this video, we did some coding exercises here. We learned how to create an order dictionary and assign keys and their associated values to an order dictionary. We learned how to access different elements of an order dictionary, for example, the key B, the key C. Then we learned how to update one key. For example, in an order dictionary, we're assigning a new value to a key that we already declared above. Here, we're updating A, and also we were updating B here. So we were updating A with 10 and B with 20. Then we learned how to move one key to the end of our order dictionary. So for example, using the move to end function, we learned how to move key B to the end of the order dictionary. And also here we learned how to move the key A to the end of the order dictionary using the move to end function. Using the same move to end function, we can send and move, let's say, one element to the beginning of our order dictionary. Here is the move to end, and now we are going to work with two arguments. First, the name of the key. Second, we write down last equals false. So this can help us to send or to move the key A to the beginning of the ordered dictionary. Again, we did the same with the key B. After that, we learned how to delete an element from our ordered dictionary. For example, we want to delete the key A with its associated value. So we learned that we can use the del keyword. Finally, we compared two normal dictionaries with each other to see if compiler sees them to be equal if the order of the keys and their associated values are different in these two normal dictionaries. For example, the normal dictionary 1 was having X and Y as the first two elements, but the second normal dictionary was having Y and X. So in this case, because they are normal dictionaries, the compiler sees them to be equal. However, when we are working with ordered dictionary, we see that this little change will lead to having two different ordered dictionary, and the compiler says when we are asking it, okay, are they equal? It says no, they are not equal. So in this video, we talked about ordered dictionaries and different operations that we can do with them. Thank you for watching.